Assalamualaikum warahmatullahi wabarakatuh. My name is Nofarina binti Taufik and my metric number is DE190046. So this is our group member and I'm from group A. And we are choose for the chapter 3 interpolation analysis based on decided authentic engineering problem for engineering mathematics 4. So I'm going to explain about the introduction. There is 4 points I highlight it here is first, a photovoltaic solar system known as a polar panel and helps convert solar energy into electricity energy. Number 2, the output power efficiency of solar certification is issued on the electromagnetic radiation generated by the sun. Number 3, a solar tracker is a solar panel that automatically monitors the sun to optimize power output. And the last one is the chosen report is construct of a single axis, and the data that is used to collect the reading time versus power. So for the objective, there is 2 points. Number 1, to solve a real world issue using Lagrange and Newton's divided difference interpolation methods by manually calculation, and number 2, by using Lagrange and Newton's divided difference interpolation techniques to get the exact result. And this is the point for question what you want to solve. This finding focus for non-measure solar tracking power in regarding the time of 9:30 a.m. and this is the data that we got. And what you want to solve, we aim to find the non-measure data from a tracking system a static solar panel. It is important because it will allow us to uncover unknown data for a certain time and estimate the power in using Lagrange and Newton's interpolation procedure, where you get the authentic problem or real data used for the problem. Okay, so for this project, we create an authentic challenge of detecting unknown data for a specific time by referring to data from a research report on ResearchGate with the title of a design of single axis sun tracking system. Okay, that's all from me. Thank you.
Greetings, doctor. My name is Dinesh. My matrix number is CE190230. Now I'll be explaining about the manual calculation. For this, we have actually used the Lagrange interpolation to solve the question. So for this part, we'll be using linear approximation to find the power needed for approximated time. So the approximated time we are using here is 9:30 or 0930. We have chosen this value this time because it is not given in the table or in the real-time data. So for an approximated value, we have chosen here is uh, 9:30. So for x1, okay, we are using the real data now, just for the approximation. So for xi, we are using 0900, which is the first value over here, and its power needed, which is 39.780, and the second one will be using 10 o'clock, or it's 1000. The power needed for that is 44.176, and then we'll move on to the equation on how to find the power over here using linear approximation. So fx equals to p1x, which is equivalent to the equation which is x minus x1 over x0 and minus x1 multiplied with f0 plus x minus x0 over x1 minus x0 multiply with f1. So our f value we have already chosen, which is the approximation of 930. So we have f in bracket 0930 equals to 0930, because over here the top we can see we have already put x minus x1, so it's 930 minus 10 o'clock, where our x1 here is 10 10 o'clock, and then down part x0 is 0900 or 9 o'clock minus 10 o'clock, and 39.780, this value is actually the power needed for x0. And then here, as you can see, the same, we just substitute the value. 44.176 is the power needed for 10 o'clock. And then once you have derived the equation, we will get to the outcome where we start for the first equation we will get 27.8460, and then for the second equation we'll get 13.2528, and once you have added that, we will get the power needed for our approximated timing, which is 9:30, and the power for that will be 41.0988 milliwatts. So that is the power for our approximated value 930. Thank you, doctor.
Assalamualaikum, my name is Naida Syara binti Zakaria, my matric number DE190020. And now I want to explain about the method manual calculation for the Newton divided difference. Okay, this is our table. Okay, for doing the manual calculation, okay, first, step 1, putting the information in the Newton divided difference has given in table. For the step 2, the first Newton divided difference is calculate as below. Okay, based on the formula, we put the value. For the Fi0, we get the result 0.1912. F11, we get the answer 0.0440. F21, we get the answer 0.2644. F31, we get the answer 0.1749. F41, we get the answer 0.1685. F51, we get the answer 0.2037. F61, we get the answer negative 0.1999. F71, we get the answer 0.1917. F81, we get the answer negative 0.1555. F91, we get the answer negative 0.2413. Okay, for the step 3, the first Newton divided difference is calculated as below. Okay, for the F02, we get the answer negative 0.0007. F12, we get the answer 0.0011. F22, we get the answer negative 0.0004. F32, we get the answer 0. F42, we get the answer 0.0002. F52, we get the answer negative 0.0020. S82, we get the answer 0. S72, we get the answer 0.0002. F82, we get the answer negative 0.0004. Okay, for the step 4, the first Newton divided difference is calculated as below. Based on the formula, we put the value. So for the F0t, we get the answer 0. Okay, based on the manual calculation for the step 4, we get the S0t to S70, we get the value result 0. Okay, this is our result based on the manual calculation. What are your findings? According to the manual calculation, we compare the final result for the approximation at hour 0930. By the comparison, we realized that all values that have been odd time were almost the same. Newton divided difference, manual calculation 42.7900 and linear approximation, manual calculation is 41.0988. Why you get this result? The manual calculation was done by consulting the book and watching the lecture video. Besides, we calculate all this result by referring to the data that has been given from the journal that we have choose. The journal is about a design of single axis tracking system. We take reading data from a solar panel to calculate the value of power at hour 0930 by referring to the hour value and power value. Why you get this finding? The result between manual calculation for Lambridge, interpolation for linear approximation method and Newton divided difference method are exactly the same, but Newton divided difference has slight difference for the final answer. There were only 4 decimal places. In addition, to make sure that we get the true result for manual calculation, we compare to method after don't finish calculation. Okay, thank you. That's all for me.